My name is Rosalind Franklin, and just to tell you a little bit about myself, I received my bachelor's from Newman College in Cambridge in 1938, where I studied various forms of chemistry, ranging from pure and physical. I later received my PhD while researching with the British Coal Utilization Research Association. However, my true passion became apparent after working with crystallographer Jacques Mering in a laboratory in Paris. Mering taught me the fundamentals of using X-ray diffraction, which was the method used in my experiment. The overall experiment was a long process, which consisted of shooting X-rays onto DNA fibers and then taking photos of the produced images. I carried the experiment in two phases. The first included a dry DNA fiber, while the second was wet. The dry was used as a control, whereas the wet was the more tested fiber due to the fact that the cells are constantly in water. I was originally assigned to perfect the X-ray crystallography unit at King's College, which then led me on the path of DNA. Many scientists believed that DNA had little importance at the time, as it looked like a blob-like structure and was simply a waste of space in the nucleus. However, I believe differently. My goal was to find the true structure of DNA, for I believe that all the material inside the nucleus is important. I was confident that others were failing to use the right approach. With my X-ray crystallography background, I knew that I would be able to find the correct molecular structure of DNA if enough time was put forth. Determining the shape would then allow me to find its true purpose in the cell. With my information on X-ray diffraction, I was hired by King's College London as a research associate in the newly introduced biophysics department. So, the experiment was performed in a laboratory at King's College London in England. Roughly after World War II ended, I spent some time studying the health hazards that coal produced, which promoted my research with amorphous substances. Being from England, it was sadly announced that King George VI passed away on February 6, 1952. His daughter Elizabeth then became Queen Elizabeth II at the age of 25. In the United States, Dwight D. Eisenhower was elected president, making him the first Republican president in over 20 years. The following year was a very significant year, especially for me, as my article was published by Nature. However, I received little to no credit as Nature published an article by Watson and Crick beforehand. This made my findings look like supporting evidence to their claim. In 1955, the United States entered the American Civil Rights Movement as Rosa Parks' arrest sparked a bus boycott. Upon arriving at King's College in London, I was supposed to be working alongside Maurice Wilkins and using X-ray crystallography. However, Wilkins believed I was assigned to be his assistant and failed to treat me with respect. Due to our frayed relationship, he and I worked in the same laboratory, but we interacted as minimally as possible. Therefore, I worked in tandem with Raymond Gosling, who was a student at King's College at the time. With Gosling's assistance, with the diffraction, the two of us were able to capture high-resolution photos of the DNA fibers. Many have asked if I have worked with James Watson or Francis Crick, but I have only briefly met Mr. Watson at a lecture I presented at King's College. I believe my colleague, Maurice Wilkins, has worked with Watson before, but I do not know if he is still doing so. So to answer your question, Jacques Mering, my mentor, and Raymond Gosling, a student, are the two individuals that have helped me with this experiment. It was my idea to bring the use of X-ray diffraction onto the table, so it was my job to make sure that the process was done correctly. I perfected the use of X-ray crystallography by exposing the DNA fibers to over 100 hours of rays, which then created the highest quality image possible. Certain calculations had to be done to ensure all angles of the fiber were hit to correctly display the image of DNA. Otherwise, it would become blurry. It was then my job to also acquire both the dehydrated and hydrated fiber samples, but this was easily accomplished through the college. After the images were produced, I began to analyze the components. My project was made possible due to the use of X-ray diffraction. I did not invent X-ray diffraction in any means, as it was discovered by Wilhelm Röntgen in 1895. However, I believe I opened the world to a new realm of biophysics, utilizing the technology of physics to understand how biological systems work. X-ray diffraction has been used to discover the crystal structure of molecules, but I was one of the first to apply this idea to the anatomy of the cell. I believe that the introduction to biophysics will promote others to create technologies used to fight sicknesses and hopefully save lives. At a young age, I took a liking to science, specifically chemistry, around the age of 15 as math and science came easy to me. My father had an impact as well, as he studied sciences in college before the commencement of World War I. He was not thrilled that I chose to go to college for physical chemistry, but offered his full support, knowing that it was for the best. My experience has been nothing short of challenging. I had little support working at R.G.W. Norris's lab due to the fact that I was a female scientist, which hindered progress. Nonetheless, through countless nights of studying, I was able to earn college and research scholarships, easing the financial side of things. Lastly, this journey would not have been made possible without my mentors, Adrian Whale and Jacques Mering, for these two are not only mentors, but friends who have pushed me to discover the unknown. Thank you.